Hello developers, let's start developing. Today we're gonna take on the daily task for the 5th of April 2024 and the task is to make the string great again. I have to say a great title. So we have a string and we need to delete some characters where we have a lowercase and an uppercase letter that are next to each other. So basically in this scenario, when we have the LeetCode string, we will need to do some stuff to it. What we will need to, we will need to analyze those e's that are in the middle. So this is an invalid pair. Or look at it this another way, this is an invalid pair. And that pair will need to be removed. So then we are left with LeetCode. In this case, this is an invalid pair, but when we remove that, then AA becomes an invalid pair, and CC is of course an invalid pair, which means that we're gonna have to remove that, leaving us with an empty string. And of course, if the string is just a string, then we don't do anything. Okay, let's get started developing. I already have some kind of a setup running here, so I will just rename the input variable as an input because it sounds better that way. So, first of all, what do we want to do? We will need to define a constant. So, that constant will be the difference between a lowercase ASCII letter and an uppercase ASCII letter. So let's see what is A. Let's see, yeah, do it like this. Since we don't know it, I kind of know what the difference is, but let's find out. So if we take the string A and do get char code at 0, and of course the uppercase will be of the uppercase, then the difference is that much. Let's console log that and see and return an empty string. So let's see if that will return a valid number. It should be 32, and it is. Of course, the test cases are failing because we're not solving the problem. So what do we do to solve the problem? We can even just hard code it because that's a kind of a constant of life. Yeah. And we can now do some things with it. And Copilot is right. I will want to have my letters basically separated. I will actually want to have an indexed. Yeah. And we're gonna do a while loop. Something like this. So until we're over there, we're gonna need to, we're at a letter and we want to check on the second letter. So basically in this scenario, we would like to check when we get to this E, when we get to the index of this E, that we need to remove this one. But how do we do that most efficiently? Yes, that's gonna be with a stack, because we will have, and actually I think that we're gonna abuse the JavaScript array, because the JavaScript array is specific in that it can behave both as a queue and as an array and as a stack. So the stack is constant actually. And of course that's gonna be a string array. and we're gonna have it like this. So we're gonna say if, yeah, we're gonna need to check now if the top of the stack, let's name some variables. So we have the current char, which is at input indexed, and then we have the top char at the stack. So this is the current and the top of the stack is actually the previous character. So we are comparing our current character with the previous character, and if their differences are 32, yep, char diff, yeah, we can do something like this. Take the absolute value of the character of the ASCII code of the top character and of this thing. We don't need the or zero part. So this will give us a value, the absolute value of the difference. Great. And if that is the difference, we're gonna do something, otherwise we're gonna do something else. So if this is the case, that means that we have a par. We need to get rid of the top character and we're gonna need to get rid of the current character. How do we get rid of the current character? Well, that part is actually very simple. We just move past it. Don't do anything, we just move past it. And how do we get rid of the top character? Well, we're gonna use the pop function of the JavaScript array, which will basically treat it as a stack and pop the thing. But otherwise, if we don't have a match, we actually need to take the current character and put it on the stack. And of course, we're gonna need to move the index. Sure, we can take index plus equals 1 above that, but let's not do that. This is not a complete method. I feel that we will have some problems with some k inputs, but in essence, the algorithm is like that. So we are pushing everything inside our stack, and at the end of the algorithm, we will only have the valid characters inside our stack, which is actually a JavaScript array. And since it's a JavaScript array, we don't need to pop in everything to get to the contents. We can just say return stack.join. We don't even need that. Join whatever is on the stack with an empty string between them, which will actually generate the string that we need. I think that we will have some errors or explosions or something like that, but let's take this for a test run anyway. It's not important to get it right on the first try, it's important to try it eventually. And we got our results, and it's a type error. Cannot read properties of undefined reading char code at line 36, character 71. Where is that? 36, I guess it's this. You might have seen that TypeScript wanted to have this here. And it's correct. Our stack may be empty. But on the other hand, if the stack is empty, where is the stack empty? Well, the stack is empty initially, so we can sidestep it maybe. Yeah, actually this algorithm will immediately break because the first time we try to do this, the stack is empty. So let's seed the stack. Let's say input of 0 is already inside of it. I think I can think of another case where this will be empty. Failed test case 1, expected LeetCode, actual LeetCode. Seems that our copilot was better at this than me. Of course, because I actually trusted copilot. And it didn't go all the way through. It didn't check the last character. So it needed, wherever it stole this code from, this line and this line were in sync. Let's see. But you can see that it executed test case 1 and then exploded on test case 2. And that is this case, A, B, B, A. So the stack, let's debug this a bit mentally. The stack becomes A, the current character is B, everything is fine. The stack becomes A, B, and we have a current character of B. We pop the B's, then the stack is A, we have a current character of A, we pop the A's, and the stack is empty, and our current character is C, and this thing blows up. I really hate seeding things like this. I would rather start at the beginning and not handle special cases, but handle special cases in a different way. So I will actually write this exact code. If the stack is empty, then we don't need to check with the current character. It's a new character. And it will also work with, this will work with one strings of length 1. So if the stack is empty, push the input, the current character, move on to the next character and continue. Yeah. Actually, we're always incrementing index. So yes, in this case, we can take it in front of the equation. But let's see if this works. Seems to. Let's add some more test cases, maybe. Yeah, that's a good one. I think it's mostly covered by the second one. Not that, but something like if we have A, B, B, A. This should leave us with A. And also this same thing. But just, no, this thing. But with a C at the end. Whether that will return, this should return a C, this should return an A, that should return an empty string. I might miss something, but on the other hand, if we miss something, the LeetCode site will tell us what we missed, and this says actual is AC. Did I mess something up? Yeah. I wanted to remove this one. The test case was wrong, the code was great. Says okay. Of course, I only wrote this code. I have no idea whether it will work. Let's try to make our string great again. So, never directly submit on LeetCode because you're gonna waste a submission. Run your code first to make sure that it's actually doing what it's supposed to do. The default test cases are running, so I will now submit it and see if I missed some kind of a specific test case. And apparently I didn't, but my code is relatively slow. I can live with it because the differences, the spread is from 50 milliseconds to 76 milliseconds. which means that if I submit it again, I might get a much better result. If I submit it again, I might get a much worse result because this range of few milliseconds is heavily dependent on the system load, but I'm fine with it. We have a solution and we can continue our LeetCode progress. Bye for now. Don't forget to mash the buttons and keep developing.